Hmm? Oh, hey. You, seem to have got me at a bit of a bad time. Huh? Where are we? I don't actually know. You know, I have been wondering something, though. How am I floating? I mean, I'm on a piece of metal in the middle of liquid. Shouldn't I just sink? In fact, that brings me to wonder, how does water even work? Well, let's find out. Alright, so the three main concepts that I'd like to cover are buoyancy, net force, and waves. I think understanding these three principles will help us understand the general ideas behind water and how it interacts with physics, starting with buoyancy. To really understand buoyancy, we should first understand where it originated and who discovered it. The term buoyancy was created by the Greek mathematician and inventor Archimedes, sometime between the years 287 and 212 BC. He formed Archimedes' principle, which explains that an object submerged in fluid experiences an upward buoyancy force equal to the weight of the fluid displaced. The equation Archimedes created for buoyancy was F of B equals rho times G times V. In this equation, F of B is equal to the buoyancy force, rho is equal to the density of the liquid, g is equal to the acceleration due to gravity, which we know is negative 9.8 meters per second, and v is the fluid volume. All of these make up Archimedes' principle, and are the key components to the buoyancy formula. Now, the next concept that I'd like to talk about is the sum of forces, which, fortunately, we actually already have the answer to. The definition of Archimedes' principle was that an object submerged in fluid experiences an upward buoyancy force equal to the weight of the fluid it displaces. The reason I emphasize the word equal there is because it is a balanced equation. The net force for buoyancy in water, the buoyant force, is an upward force equal to the weight of the water displaced by the object, meaning that if the object is floating, then it is at equilibrium. Huh. Okay, so that explains why I'm still afloat. However, what about the bobbing up and down? Starting to feel seasick. Wait, pause for a second. That's not a bad question. So, how do we answer it? Waves are something we see a lot in daily life, and it's not just a pattern associated with water. In things like waving hello, radio waves, and ocean waves, we tend to see this similar pattern between all three. So, what is this pattern, and what makes it the way it is? The fundamental wave formula in physics is v equals f times lambda, relating wave speed, v, to its frequency, f, and wavelength, lambda. There's also wave period and amplitude, which wave period is the time it takes one complete wave cycle to pass a fixed point, measured in seconds between the wavelength, and amplitude is the height of each wave. The frequency of the wave is the measure of how often a repeated event, like a wave oscillation or vibration, occurs per unit of time, typically 1 second, measured in hertz. This makes period and frequency heavily related. Okay, I think I'm starting to get it now. Well, I should probably get back to whatever I was doing. Anyways, thanks again for watching. I hope you enjoyed. This has been Harry Bradbury. Goodbye.